All right, I've gone ahead and started this one out here. So this is number 9, and we've got the limit as x approaches 2 of x squared minus 3. If you plug 2 in, then 2 squared is 4, minus 3 is 1, and so the limit is 1. And we know that the limit exists on both sides because this is a parabolic. By the way, it just they both exist if we're talking about any true polynomial. So I believe we had a theorem about that in one of them, might be 1.3. And so number 1, our function is x squared minus 3. 2, we need a c value, which is 2. X tends to c. Number 3, we need a limit of 1. And number 4, we need an open interval, and so I chose plus or minus 1 on the center, which is c. And so that's 1, 3. Okay, now in number 7, I didn't include this, but what I really should have said is from number 7, so from 7, let delta equal the minimum of 1 and epsilon. Because if epsilon is larger than 1, we want the smallest one that's possible. We're going to use that same idea here. All right, so let's go ahead and start it out. We have to show that for all epsilon greater than 0, so for all numbers greater than 0, there exists a number that's greater than 0, such that if the distance between x and 2 is smaller than delta, then the distance between the function value and 1 is less than any number epsilon. Okay, so we're looking at a distance here. So we're squeezing it down. All right, so just as we did before, we're going to use epsilon to derive delta. And so I'm going to start right off with epsilon. Okay. And so because of this, we can go ahead and kind of expand this out. And so inside negative 3 minus 1 is a negative 4 is less than epsilon. And so that gives us x squared minus 4. Now, we have to be careful here. Because we want the minimum between all these, we want to find out there'll be an involvement of a maximum here. Okay, so now we notice that we have the difference of 2 squares. I'm going to split that up into x plus 2, x minus 2 is less than epsilon. All right, now this is where our maximum comes in. Now we know that we're going to squeeze this distance down to almost nothing. However, this number here can be a maximum value. And so because a maximum value times whatever this happens to be will maximize that whole value, I need to find out what's the largest that this can be. So what is the largest? The largest. So now let's go back to our interval. We know we're going from 1 to 3. And so now what is the largest that this can be? That's a linear function, and so it's increasing. And so at the upper limit of 3, then you'll have the largest. And so that's the absolute value of 3 plus 2. The 3 came from our open interval. And because the open interval, we cannot include 3, we know it's going to be slightly less than 3. That just shows. So you have, I'm going to kind of show that over here. Now we want that stuff to be less than epsilon. Okay, so we want this to be less than epsilon. We know that if we put in a 3, we know that 3 plus 2 times x minus 2 has to be greater than, I'm sorry. Has to be greater than x plus 2 times x minus 2. And the reason for that is that we cannot include 3. 3 is an upper bound, but we cannot include it. It's not a closed interval, it's an open, so we cannot include 3. And so that way, if we do, then we know our answer has to be less than that, which means that because 3 plus 2, those are absolute values, times x minus 2, we're going to make that less than epsilon. And by chain, we have this. Okay, so I'm forcing the issue. I'm essentially squeezing it. But I'm squeezing it below this underlined in purple. And so I'll force the end result to be less than epsilon. I don't know how better to explain that right at the moment. That might take like a separate video and just talking about it. But we're looking for a maximum value, because if we multiply x minus 2 by some number, it's going to increase its value. And so we want to find out what that maximum is so we can make sure it's absolutely less than that. So coming back down here, here's the maximum. And so I've got 5 times x minus 2 is less than epsilon. Dividing both sides by 5, I get x minus 2 is less than epsilon over 5. Okay, so now I have this, but if we look up here, we need to prove that x minus 2 is less than delta. That's the same form as what we have here. X minus 2 is less than delta, is less than delta. So what we're going to do is choose our delta to be the minimum of 1, which is our limit, which is our interval that we chose, or epsilon over 5. Okay? And so we're going to work with epsilon over 5 because in 1, it just kind of peters out. And so it's traditional that because epsilon is a variable in this case, that we haven't found epsilon yet, or we haven't defined it, it becomes somewhat of a floating constant. Not quite a variable, but a floating constant. And so we're just going to mess with that. So now, let's go back and let's say x minus 2 is less than delta. Okay, that means that x minus 2 is less than epsilon over 5, which means that 5 times x, or the absolute value of x minus 2 is less than epsilon. From there, that means that 3 it is not obvious, but 5 is equal to 3 plus 2, and the absolute value of 3 plus 2 times x minus 2 is less than, I'm sorry, is greater than, hang on, let me stop here. Okay, all right, I just had to clarify something in my head quick. All right, now, we have chosen this because 3 plus 2, the 3 is our maximum value up here, up a little further. The 3 is our maximum value, okay, from our interval. 3 plus 2 then is going to be greater than whatever x plus 2 can equal. All right, since 3 plus 2 is 5, then 5 is greater than anything that x plus 2 is equal. That means that 5 times x minus 2 is less than epsilon, but it's also greater than x plus 2 x minus 2. All right, well, that means that if you multiply these two together, remember that the product of the absolute values is equal to the absolute value of the product. And so back inside, we have this is less than 5 times x minus 2 is less than epsilon. Okay, this inside becomes x squared minus 4 is less than 5 x minus 2 is less than epsilon. And because this is less than this, and the 5 times the quantity, or the absolute value of x minus 2 is less than epsilon, the chain says that this must be true. And so now if we rewrite 4 as negative 3 minus 1, then we have x squared minus 3 minus 1 is less than epsilon, and therefore x squared minus 3 minus 1 is less than epsilon, and this is what we had to show. Okay, these things can get kind of messy. And so it really ends up being, anytime you're working with an absolute value or a quadratic, that sort of thing, something that kind of backs up onto itself. We need to choose we need to go this route where we actually start choosing a maximum value here. what's the maximum value that that function can be if we split it up. And that's where that comes from. All right, so because we've gotten back to what we needed to show, we are complete with this particular proof.